use.
We started our discussion for the Hermite spline curve, defining each component of Rx, which is the second equation, second Hermite spline curve, as a function of third order polynomial equation. And we collected 4 group schools, if you remember, 4 group schools to solve the for CJ. Okay? To solve CJ, we collected 4 clues. That gives us this formula. Again, whenever you are trying to solve something unknown, the first place where you have to search for is when certain along boundary. So I told you that the boundary condition is very important to solve the unknown. And then the boundary, the value, the current value of the boundary is very important. But if you can't solve the known completely, you have to search for what? Search for change of that value. And if you can't solve it still, you have to search for what? Change of that change of boundary value, okay? So that was the general approach. When you're facing with something you can't solve, right? The boundary always has some information. Either its own value or like changing of the value or changing of the value. So we collected the 4 information with the boundary values, 1, 2, and then the change of the boundary values, right? Totally. So we put them all together in one form, in one matrix form. That's why we stopped last time. The thing is that if you just define these as A and B, this matrix A and that matrix B, then nice thing about is that A should be Cj times B, and then from here we can find Cj by doing what? Multiplying B inverse, right? So that means A times B inverse. That's your Cj. One thing left over is B. B is okay. B is all this constant. Everything is known. But A right here, if you look at A, not everything is known. Well, because of the fact that the most likely when you are trying to draw a spline curve, you are not going to probably provide what tangent information at each point. You don't want to draw all the tangent curves, right? You just plot those numbers. I mean those control points. That the computer does everything. So for the sake of our laziness, somehow we need to find out these. We need to actually provide another mechanisms, okay, for the robot, not the robot, the computers to find these out, okay, find these out. So that's basically the study point for us today. So how do I do it? Well, as I said, whenever you're facing something unknown unsolvable problems, you search for the boundary values, change of the boundary values. If you still can't solve it, you have to go for what? Change of that change, which is T double prime, right? T double prime. So if you are thinking about some curve like this, the next Blue's clue is coming from the curvature. What is the curvature? Curvature is the same as the double prime. That's the definition of curvature, right? And if you think about it, whenever you try to connect these control points, the curvature at each point, when you approach from the left or from the right, okay, let's say the curvature right here, the curvature right there, no, curvature right here, so it has to be on the concave side. What if these curvatures are not the same? If this curvature is not the same? You may have something like this, and then you may have a smooth transition because you assume that because of the fact that you find the tangent at that point. Tangent should be, for example, go like this. But if curvature is not the same, this may go like this. You have curvature, this curvature is smaller than this curvature. Does that make sense? Just kind of intuitively, like I'm trying to give you some plot, some difference between the curvature. If curvature from the left is larger than the curvature to the right, at that point of contact, you will have a very kind of a weird shape of the line. It's not smoothly connected line. So that means the curvature R, say this is n minus 1 right here on the left. Okay? The curvature R is double prime, and approaching from the right, double prime, has to be equal. But what is the value of the, what is the lambda value at this point for Rn minus 1 right there? If this is R, right, this is Rn minus 1 equation. Lambda start from 1. 0 to 0 to 1. So that the curvature value at the point, lambda has to be 1. How about the lambda value at this one, for this segment, which is Rn now?
0.
Starting from 0, right? 0.
0.
Has to be 0. And these to be equal, this has to be equal. That will basically make this curve, the whole curve looks much smoother. They satisfy that they have the same tangent at this point. However, if curvature is not the same, if curvature is different, then the actual curve is not going to be looking smooth, right? So in order to make the line smoother, you have to make sure that these condition has to be met. So that's basically our next blue script, right? To solve for what? Solve for these. These are knowns right there. Okay? Let's just go step by step and see how do we actually apply this condition to find these knowns out, right? So, as I said, R, J, or same thing, N or J, same. R, 0, 2. Same equation. I just changed the N to J. N is the last point, but J is just generalized index to point out something in the middle. So in order to actually set this up, I need to find out Rj, or double prime. What was Rj prime? Rj prime is Cj. What was that? 3 lambda squared, and then what? 2 lambda? 1, 0. Now I need to know the R double prime, which is Cj. What is it?
6 lambda.
6 lambda.
2.
2.
0.
0. Okay. Make sense? 6 lambda. 2, 0, 0. Just one derivative from here. So I'm going to just apply this into this this equation. Okay. So that means that the Cj with lambda is 0. What is it? 0, 2, 0, 0. Next one here. C is minus 1. And lambda is 1, what is it? 6 to 0. So that has to be met. Okay? So now what I want to do is to just see, I'm going to use this equation right here, plug that into this equation, because this one has the unknown Pj and Pj plus 1 primes. Okay? I'm going to plug this into that equation somehow to correlate them together with that information of the curvature. Okay? Curvature. Let's see what happens. So if I plug this in there, it's going to be Cj should be, Cj is what? Cj is the A times inverse of this. So in effect, it comes right here. Pj plus 1 prime. And that's inverse of this, whatever inverse, B inverse, this is B, times 1 now, times 0, 2, 0, 0. Correct? This has to be equal to 1 now. Now I have to go with, see, j minus 1. That minus 1 means everything has to be subtracted by 1 in it. J1 minus 1, j minus 1, j, right? J. So that means P, j minus 1, j minus 1, j prime, and then B inverse, times 1 now. What is it? 6200. Okay? Now, I just have to multiply these together. I'm going to skip that part, and then I'll give you the result. One B minus 6 minus 4 6 minus 2 here you have 6 2 6. That's what we got so far. Again, this equation is coming from that equation right here, the condition that we set up to make the line smoother, okay? To equalize the curvature at each point from